Hello everyone, welcome to this second unit in block 4 on test of significance and attributes. Let's recall what we have studied in the previous lesson. It was about introductory part of hypothesis testing. So we said what are the steps that are involved in hypothesis testing. That is about setting up of a hypothesis, level of significance, test statistic, calculation and decision. Now let's understand what this word attribute is and what are the tests that are related with attributes. Now what exactly is this word attribute? Now before that we go into understanding attribute as it could be anything to do with things which cannot be numerically measured. It could be quality, features, characteristics. Suppose I talk about a person, his age, his height or his weight. These are things which can be numerically measured and expressed in numbers. So that is what we call it as quantitative data, and that is where we call it as the variable part of it. But if I say a person is sincere, honest, punctual, there is no yardstick with which you can measure it. And these things which you can't measure and express in terms of numbers, we call it as an attribute. Now whatever measurements we take, it can be categorized into two classes, whether it is discrete or it is continuous. Now, if we go about measuring somebody's height, weight or age, it comes with decimal values. Now, that is what we call it as discrete. But suppose we count the number of people, we can't represent in terms of decimals. So, things which can be represented in decimals are called continuous, and things which cannot be represented in terms of decimals but as complete whole numbers, we call it as discrete. So we already said what is qualitative and what is quantitative. Things which can be measured and expressed in numbers are called quantitative data. Things which can't be measured and expressed in numbers are called qualitative data. So what is attribute? It is to do with the characteristic. It is a feature where you can tell only presence or absence of that feature, but we can't measure and we can't compare it, or we can't put it on a yardstick. Variable is something which we can measure and express in terms of numbers. Now the numbers that we normally deal in our day-to-day life can be either called as nominal, ordinal, interval or ratio. As students of Dr. B.R. Ambedkar Open University, you must be having an hall ticket number. Your results are declared based on the hall ticket number. It is a number, but the thing is you can't do any mathematical calculations based on your number and your friend's numbers. This number is meant for your identification. Like what you give for a cricketer as a jersey number, or an athlete has got a chest number, or a footballer has got a jersey number. It is meant for identification and not for calculation. Suppose I say there are 3 students whose ranks are first, second and third. Now I can't tell based on the position of ranks as 1, 2 and 3 as to how many marks the third rank student lost the first rank. It can only tell you the position. So the thing is, these numbers which denote position are called interval. The third category is whenever I read the Deccan Chronicle paper, I come across the temperature, whether it is maximum or minimum. What can I do with this data? I can find the mean, I can find the range, difference between the maximum and minimum. Beyond that, there is very little mathematical usage of these two numbers. Now they are called as interval. Now those numbers with which I can do a lot of mathematical calculations, they are called as the ratio numbers. So what is an attribute? An attribute and a variable are fundamental concepts in statistics and data analysis, representing different types of data that can be collected and analyzed. An attribute is a characteristic or quality of an object, an individual or entity that can be measured or observed, but it can't be numerically expressed. They are also called categorical in nature, meaning they represent distinct categories of groups. I would say male, female, right? I just distribute them, rich, poor and middle class. It's an attribute. Now, what are the types of attributes? When we say nominal attribute, it represents a categories with no inherent order. It could be the color of the skin, color of the eye, gender. You can't measure it. You can say you either belong to male, female or others. Now ordinal attribute goes about with representing the categories with a meaningful order or ranking. It could be the level of education. You could have been passed out of a school or a +2. You could be possessing a bachelor's degree or a master's degree or a PhD. Now, the customer satisfaction level can vary anywhere along poor, fair, good, excellent based on the feedback. Now, what is this thing to do with attribute? It can describe qualitative. Get it right? It is not quantitative, it is qualitative data. Now, they can be counted, but you can't measure it. Now, operations like counting the number of occurrences are possible, but arithmetic operations like addition, subtraction are not meaningful for qualitative data. Now, what is a variable? It is a characteristic or it is a property that can take on different values. Variables are typically quantitative and meaning they represent numerical measurements or counts. The types of variables are continuous variables. As I said, it can have decimal values. Height can be 170.5 centimeters, weight can be 65.8 kgs, temperature can be 22.3 degrees centigrade. Now, discrete variables, they can take only specific separate values like number of children in the family. It can be 0, 1, 2, 3. Number of cars on the road, it can be any number, but it can't be represented in decimals. Now, what are the characteristics of variables? Variables describe quantitative data. They can be measured and subjected to arithmetic operations. So, analysis like calculation of mean, median, standard deviation and all other kind of calculations are possible when you talk about a variable, but not with a attribute. Now, the key difference between attribute and a variable is attributes are qualitative, they are categorical data, and variables are quantitative or they are numerical data. Now, the type of operations are for attributes we do counting or frequency analysis. Variables we can do addition, subtraction, find statistical analysis like mean, variance. So, examples for attribute can be hair color, the marital status, whether you are married, unmarried, or you are a divorcee or you are a widow. It can be a type of vehicle, whether it's a sports utility or a family car or it is a single utility car. The variable can be age, income, test scores or marks that you get in an exam. Now, example to illustrate the differences, suppose it is to do with an attribute. Now, people are being surveyed as to what is the favorite type of cuisine, whether it is Chinese, whether it is Italian, whether it is Mexican or whether it is Indian. Now, the thing is, it is to do with categorical, whether you like Indian food or not, whether you like Chinese food or not, or fast food or not. Now, variable is about measuring the height of students in a class. So, understanding the distinction between attributes and variable is crucial for choosing the appropriate statistical methods and analysis. So, attributes often require different kind of analytic techniques. Basically, we talk about chi-square tests. And please remember this thing, if we want to find the relationship between numbers, we use a concept which you have recently studied in the same quantitative techniques, which is to do with correlation. If you want to study the relationship between the attributes, we use a concept called association. Suppose as a teacher, I want to figure out how many marks you got in cost accounting and how many marks you got in quantitative techniques. Is there a relationship between these two? Or the marks you got in organizational theory and behavior to the marks you get in quantitative techniques, is there a relationship? One is theory and another is a numerical paper. Now, I have the marks, I can find whether there is correlation or not, right? Now, if I want to go about with trying to figure out the things as to whether there is association, that is, people who are more educated get jobs or people who are less educated get jobs. Or if I am trying to compare people who are educated are more prone to criminality or people who are less educated are less prone to criminality. Or we have studied it in our school days when it comes to genetics. We inherit our parent qualities. If it is the way I look, it is because I have inherited the genes of my parents. Or let's say we want to check for the sake of research, do angry fathers go about with generating what is called as angry sons? Or is it because of cool-tempered mother that the kid is also cool-tempered person there? So here we don't go about with using what is called as correlation, because it is quality, it is characteristic, it is an attribute. We use a concept called association for that. So when it comes to variables, what you'll study in the later part of this course, we study about t-test, z-test, ANOVA and other things there. We look for test of attributes. So what is this thing? Before we go in further, again we go about with trying to summarize that nominal and ordinal. So we have what is called as qualitative, which is called as the categorical data, or we have what is called as the interval and ratio, which is called as the quantitative, or it is called as the non-categorical data. The scales of measurement are, please remember this in mind, because in the previous video we have discussed that what is parametric and what is non-parametric test. Now if we know about the parent population characteristics and we apply statistical tools on them, we call such test to be as the parametric test. If we don't know the parent population characteristics, and on such samples when we apply the statistical tools, we call it the non-parametric test. And under parametric we have given examples like z-test, t-test, ANOVA, one-way, two-way and other things there. And under non-parametric we talk about chi-square test, Kruskal-Wallis test, Mann-Whitney-U test, lot of them that are there. And normally what we see is the nature of the number also influences what is the choice of statistical tool that we test. If the nature of the data is nominal and ordinal, we go about with using what is called as the non-parametric test. If the nature of the data is that of interval and ratio, we go about with calling it as the parametric test. Now what is this chi-square test? We'll come to this symbol. It's very easy to remember. It is to do with inverted English alphabet S with a diagonal and a square symbol, just like we say a plus b whole square. Now when we write it as CHI, but when we pronounce it, we don't call it as chi square or chi square, rather we call it as the chi-square. So when we write it as CHI, but when we pronounce it is KI. So we call it as the chi-square. So this is one of the common test of attributes, and we'll see further details again in another unit on chi-square there. Now this is used for a few reasons. One is to check the goodness of fit. It is used to check the independence of attributes. It is used to check the test of homogeneity. Now what is this goodness of fit? If you remember what you studied in the third block, there was this binomial distribution, Poisson distribution and normal distribution. Now let me take the binomial distribution. Now if we go about with tossing 8 coins and figure out what are the chances of getting heads, which could range from 0 to 8. Suppose we repeat this experiment for 256 times, right? If we physically do this, I'm not sure about how much time it would take, but if we can use the formula of binomial distribution, what we are trying to do is we are trying to figure out the expected frequency. If we literally take 8 coins and toss them and find out the results, that is what we call it as the observed frequency. Now we want to find whether there is a fit between the observed and the expected frequency, and this is what is the test of goodness of fit. We can do it for binomial distribution, we could do it for Poisson distribution, we could do it for normal distribution as well. So that is where we go about with looking for the goodness of fit. So normally it is about trying to check whether there is a fit between the observed and the expected frequency. So we check whether the sample data matches with the population, and let's say another example, we toss or we go about with rolling a die. The die has got 6 sides ranging from 1 dot to 6 dots. Now we want to see whether the die is giving randomly the odd sides or the even sides, the odd represented by 1, 3, 5 and the even represented by 2, 4, 6. So you want to see whether the die is biased. So we would throw any number of times and figure out the observed frequency and compare it with the expected frequency and find out whether the die is biased or not. Now what do we do in the next one? That is test of independence. This is used to determine whether there is a significant association. As I said a little while ago, that if we want to check the relationship between the characteristics or features or properties which can't be numerically expressed, but you can tell whether presence or absence, right? The complexion of the father to the complexion of the kid. Now we are talking about presence or absence. So if you want to find that, we don't use correlation, but we use a concept called association. So it is done between two categorical variables. So you compare observed in a contingency table to that of an expected frequency. So testing if gender is independent of voting preference. Suppose men prefer a particular party or women prefer a particular party. So voting is personal choice, right? You vote or you don't. Gender, whether you're a male or a female. So we are trying to check whether these two attributes are independent. As I said a little while ago, whether we check the association between employment and education. So when it is education, we take literate, illiterate. Among employment, we take the ones who are employed and the ones who are unemployed. And for symbolic reasons, what we say is the presence of that attribute we indicate with an English alphabet A, absence of the attribute with alpha, English alphabet B for the presence of the other attribute, absence of that attribute with the Greek notation, that is beta. So we go about with checking on these things there. And suppose we want to check the test of homogeneity. This is used to determine if different samples come from the same population with the same distribution. Suppose we go about with drawing people from Secunderabad and Hyderabad. Now we go about checking various kind of things on them, various statistic details we collect, and we want to figure out whether both of them belong to the state of Telangana or not, right? So that is where we call it as test of homogeneity. So similar to the test of independence, but used when comparing two or more populations, testing if distribution of blood types is the same across different ethnic groups that are there. Now there is a Fisher's exact test. This is another test of attribute used for small samples sizes to test the independence of two categorical variables. Remember, categorical variables are the nominal and the ordinal. Non-categorical are the interval and the ratio. So testing the association between treatment type and recovery in a small clinical trial which is done under experimental basis. There is another variant of chi-square test which is called McNamara test, which is used for paired nominal data to test for changes or difference in proportion. So if you want to check is there any significant difference in opinion before and after an intervention, before taking a medicine and after taking a medicine, before the star campaigner goes about with speaking about the party, whether the opinion of the people has changed before and after is speech there. So we have what is called as the McNamara test. Now we check into the key steps that are involved in test of attributes, very much like what we said earlier too. We do the same thing. The same steps what we studied in the introduction to hypothesis testing is what we go about with doing here also. So what we do for test of attributes is we state the hypothesis, that is null hypothesis, saying that it assumes no effect, no difference, no association. Now, there are people who have taken vaccine during the COVID time. So these people are vaccinated, and there were some people with fear of side effects, didn't take the vaccine. These are non-inoculated. I want to check the efficacy of whether the vaccine goes about with helping somebody to get COVID or not. So having COVID is A, not having COVID is alpha. The one who is vaccinated is B, and the one who is not vaccinated is beta. So I'm trying to check whether there is association between getting vaccinated and getting the disease there. So alternate hypothesis, we say it assumes effect, there is a difference, or there is an association. And as we have rightly said in the earlier video lesson also, we said what is level of significance, and it is to do with the chances of committing a type 1 error or our hypothesis being right and the chances of rejecting it. So we talk about it being either 5% or 1%. It is denoted with a Greek letter called alpha. Then we compare the test statistic and we work out the critical value, you got to remember if the standalone data is given, that is a single strand data, for calculating the degrees of freedom, the formula is k minus 1. If there are 10 sample values, the degrees of freedom becomes 10 minus 1, 9. Suppose it is a contingency table, 2 by 2 table, just like what I said now about getting inoculated, not inoculated, getting COVID and not getting COVID. This is typically a 2 by 2 contingency table. So the number of rows are 2 and the number of columns are 2. So for finding the degrees of freedom, the formula used is C minus 1 into R minus 1, where C stands for the number of columns and R stands for the number of rows. So based on, if it is a 2 by 2 table, then it becomes 2 minus 1 into 2 minus 1, which is 1 into 1, which is 1. So under 5% level, for a 1 degree freedom, the table value is 3.84. You can check it later at the end of your reading material. The standard table values for z-test, t-test, chi-square, ANOVA are given. So we go about with working out that, right? So this is something which will help you out even with ANOVA. And we collect the data, we analyze the data, and we go about with representing it in the form of tables. So if the test statistic exceeds the critical value, we reject the null hypothesis. And we draw a conclusion and we interpret in the context of the research question whether the null hypothesis is to be accepted. If it is accepted, what is our conclusion? If it is rejected, what is our conclusion? Now, the typical chi-square formula is to do with O minus E square. It is summation divided by E, wherein O is the observed frequency and E is the expected frequency. It's very easy to remember chi-square formula. And remember, there are certain conditions, that is the values when it is a 2 by 2 table, it can't be below 5. And there is something wherein we go about with doing what is called as pooling, and we ensure there is the value of the cell is not below 5. If it is below 5, we have to do what is called as AIDS correction. So just look into the material as to what is this AIDS correction. And because of the squaring of the values, chi-square test is always a right tail test. There are no negative values. So we have seen what is one tail, two tail in the previous video lesson. The formula is very simple. Chi-square is summation of, in the numerator, we have O, which represents the observed frequency, E, which is the expected frequency. So square of the observed and expected divided by the expected, summation of this gives us the calculated value of chi-square. And chi-square, the concept was introduced by this famous statistician by name Carl Pearson. So it is used to generate a statistic with which we take decisions. Chi-square test is a statistical test commonly used for testing independence and goodness of fit. So testing independence determines whether two or more observations across populations are dependent on each other or whether there is one variable which helps to estimate the other. So testing for goodness of fit determines if an observed frequency distribution matches the theoretical frequency distribution. Now you see the connection between your third block where you have studied probability and probability distributions, where you have done, now there's another reason, why do you call it theoretical distribution? We are not doing anything physically. Now let's say that I am trying to figure out what is the expected number of heads I get when I toss a coin for 5 times or 8 times, repeated for 32 times or 256 times. I'm using a formula. What is that? NCR, P to the power of R, Q to the power of N minus R, right? Where P is the probability of success, Q is the probability of failure. So you recall your binomial distribution formula or your Poisson distribution formula. What we are trying to figure out is the theoretical distribution or the expected frequency, and we want to find out whether there is a match or a mismatch between the observed and the expected frequency. Now conditions, again, the observed are recorded and collected on random basis. All items in the sample must be independent and no group should contain an item which is less than 10. But some statisticians also call it as 5. And it is also important that if you go about taking total observations, the total must be 50 or more. So if the sample size is below 50, you cannot conduct a chi-square test. And the formula again, when I said for goodness of fit or for test of independence, chi-square is sigma, where we say it is square of the difference between the observed and the expected divided by the expected frequency. Let's look at some examples. Now here again, O stands for the observed frequency, E stands for the expected frequency, and there is the summation. And I told you the symbol, which is a Greek notation for chi-square, is to do with an inverted S with a slant or a diagonal with a square symbol across it. Now what is this goodness of fit? I said it enables us to see how well does the assumed theoretical distribution such as binomial, Poisson, normal fit to the observed data. So when the calculated value of chi-square is less than the table value at a certain level of significance, that is 5% or 1%, the fit is considered to be good. And if the calculated value is greater than the table value, the fit is not considered to be good. So we reject the null and we accept the alternate. So in goodness of fit, our statement for the null hypothesis is there is no difference between the observed and expected, and we say the goodness is fit. The fit is good. The alternate hypothesis is there is difference between the observed and expected frequency, and it is said to be, and goodness of fit that you have does not exist there. So let's take an example. A personal director, you want to check out of 180 people how they are rated on different methods, and we go about with putting it as what is, out of 180, the expected is 60, 60 and 60. The observed is there, so we find the difference. The calculated value of chi-square is 6.3 and the critical value is 5.991. So as the calculated value is greater than the critical value, we reject the null hypothesis. This is for a single strand data where the degrees of freedom, if we have 3 values, it is 2. Suppose we have it as test of independence. How do we calculate the expected frequency? The formula is row total into column total by the grand total. So this is the formula that we have. And let's take an example. These are the table values. And here we have questionnaire which is developed and sent to 90 voters. And it's an American kind of a thing there, where we talk about how many would select a Democrat or a Republican, how many are in favor, how many are neutral, and how many are opposing. So we have the observed frequency. Based on it, we take the row total and column total to generate the expected frequency values, and we compare the observed and expected to say. So here we say there is no difference between the Democrat and the Republicans, and we say there is difference. And when we calculate, we get the chi-square value to be 11.03, and the table value, if you go about, is 5.991. So as the calculated value exceeds, we say the null hypothesis is to be rejected. So all in all, test of attributes, if you go about looking at, is for things which you can't measure and express through numbers. So test of attributes, we use chi-square either for goodness of fit or for independence of attributes. So the same steps that we use in the introductory part of hypothesis testing, setting up of hypothesis, level of significance, critical value, using chi-square, and doing the calculations and drawing a conclusion is what we follow in this unit as well. And the steps remain the same, whether you do it for z-test, for large sample, t-test, the small sample, and the other hypothesis testing which is there as a part of block 4. Thank you and see you again in another video lesson.